Assalamu alaikum, bachcho. So today in the lesson, we are just going to discuss chapter number 2 of IGCSE and O-level chemistry, right? And the name of the chapter is going to be atoms, elements, and compounds, right? So first of all, beta, we need to know that what is an element, what is a compound, what are the atoms, right? So atoms are the smallest particles which cannot be further divided. And what is an element? Element is a pure substance which contains only one type of atoms. Like we say that sodium is an element, magnesium is an element. So sodium will contain only the atoms which are sodium atoms. Similarly, magnesium is an element, a pure substance which contains only one type of atoms, the smallest particles from which the element is made up of. So it contains one type of atoms. A pure substance which contains one type of atoms, which cannot be further divided into simpler substances by chemical means. Or you even can say that the element is a pure substance which contains same number of protons. All right. So, so an element is made up of identical atoms, same atoms only, and cannot be broken down into or two or more simpler substances, right? So this is going to be definition of an element. All right, or you can say a pure substance which contain only one type of atoms, right? Now, the element they just exist on their own. They are going to be natural elements, and then the elements are classified according to their proton number in the periodic table, right? The elements have definite set of their properties, right? Um, and that what is the method of separation? They can be separated by chemical and physical methods, right? Different elements can be separated. The examples of elements are sodium, iron, copper, hydrogen, like diatomic molecules like hydrogen, oxygen, chlorine, right? So they're considered as elements, right? What is a compound? A compound is made up of two or more than two types of elements, which are going to be chemically combined together, and they exist in the fixed ratio, right? So compound is made up of two or more different elements, like we can say water, carbon dioxide, ammonia. So they are compounds, right? So they are just going to made up of two or more different elements, and and you are going to break down these compounds by chemical means, right? They can be broken down into its components, into its elements by chemical means, right? And they just exist in compounds form, and the component elements are present in definite proportions. Like we always say that the in water the ratio of hydrogen and oxygen is always 2:1, right? So they're just going to occur in the definite ratio. They have definite set of properties. They can be separated by chemical methods only, not by physical means. Examples of There are various examples of compounds like zinc chloride, water, nitrogen dioxide, and many more. Okay, but they exist in the fixed ratio. Okay, what's a mixture? Is made up of two or more substances mixed in any proportions, right? And those substances retain their properties. Like if you're just going to say salt and water, right? So it's going to be a mixture. Now that they are going to retain, both of these are going to retain their own properties, and they can, they can be mixed in any proportion. They do not exist in fixed ratio, right? Do not have a definite set of properties. They can be separated by physical methods only. Like you can separate the mixture, like you can say that like mixture of soluble dyes, mixture of soluble substances on the basis of solubilities can be like separated by chromatography. We'll be doing this in chapter 12, right? And then mixture of salt and water can be separated by distillation or by evaporation, right? So they can be the mode of separation of separating the mixture components is going to be physical methods only, right? Gunpowder, potassium chloride solution, like in aqua solution, salt and water, salt and sand, like they can be separated by filtration, like or you can say or by you can say that distillation or evaporation. Okay, so this is the main differences between elements, compounds, and mixtures. Sometimes it happens that they're just going to give 1 or 2 marks definition, and in in structured question, and the question number one can be asked about it, what's the mixture, element, and compound, right? So that is the basic. And the second objectives of this chapter is going to be the atomic structure, right? The charges of electrons, protons, and neutrons, then you're going to discuss the electronic structure, and then after that we will be proceeding to the chemical bonding, right? I'll just be dividing this unit into two. In today's lesson we'll just be doing till atomic structure then. Okay, now, so in atomic structure, that we are just going to define describe the structure of an atom, right? So atom is the smallest particle of an element. All right. Now, it also contains subatomic particles, like atom is composed of a small nucleus, right? Which contains protons, which are positively charged particles, and neutrons, which are neutral, which have no charge, okay? And the nucleus. Now, the nucleus, around the nucleus, there are going to be the shells where the electrons revolve around the nucleus in the shells, okay? And the electrons are negatively charged particles, okay? So we see that the electrically, what is the charge over the nucleus is going to be positive because protons are positively charged and neutrons are neutral, right? Now, if I'm just going to talk about that, what is the electrons? What is the relative charge of electron is going to be what is the charge over electron is going to be -1. What is the mass of electron is going to be 1 upon 1840, right? Through the calculations, it is found that the electrons are going to be, its mass is negligible or it's going to be 1 upon 1840, right? Now, if I'm just going to talk about protons, so protons are positively charged particles. They are going to have +1 charge and the mass of proton is going to be 1, okay? Similarly, when you're going to talk about neutrons, they have no charge, neutral. So I'm going to write on 0, right, or neutral, and that the you can say the mass of neutron is going to be 1, okay? So we need to retain these the charges and that the relative masses, okay? Now, so we said that the atom is composed of subatomic particles, which are electrons, protons, neutrons, and the nucleus, protons and neutrons exist, and around the nucleus the electrons revolve in the shells, right? The lightest particles are going to be electrons, okay? Now, in the periodic table, there are different elements which are arranged according to the increasing order of their proton number, right? We are just going to deduce the atomics, like you can say the symbol of an element, all right? So then we are just going to discuss about the electronic configuration, and then you will just be predicting that their group number and the period number, right? I hope you're getting it. So now see, like if I'm just going to talk about sodium, yeah, that's going to be a symbol of sodium because you can say sodium is starts from S because the Latin name of sodium is natrium. You don't need to know, but you can even see from the periodic table that you'll find out sodium symbol is Na, right? So proton number of sodium is 11 and mass number of sodium is 23. Okay, so what do we call this smaller number is known as proton number, right? So how are you going to define a proton number? Like in IGCSE, it is asked about this, definition, 2 marks definition. So proton number is the number of protons in the nucleus of an atom, right? So number of protons, 1 marking point in the nucleus of an atom, right? In the nucleus of an atom, right? And then O-level students can just write on 2 marking points to get 1 mark. So number of protons in the nucleus of an atom is said to be the definition of proton number, right? Now, you just remember that there are going to be equal number of electrons and protons in the neutral, atom, right? Which has not, gained or, lost any electrons. So the number of electrons and protons are going to be the same. Yeah. So now let's move to the bigger number. So bigger number is known as mass number, or it's also known as nucleon number. Okay. So we say this bigger number is mass number or nucleon number, right? And how are you going to define a mass number or nucleon number? So this is said to be as the total number of protons and neutrons in the nucleus of an atom, right? So mass number is going to be total number of protons and neutrons, right? It's going to be total number of protons and neutrons. Again, 1 marking point, where does it reside, right? So total number of protons and neutrons in the nucleus of an atom, right? I hope it's clear, in the nucleus of an atom, right? Now, when through the giving symbol, you can just deduce what you can just deduce the number of electrons, protons, and neutrons. Okay? So that's going to be total number of protons and neutrons in the nucleus of an atom is going to be the definition of mass number or nucleon number, right? We'll also be discussing about the mass number is also known as relative atomic mass, right? When you're doing stoichiometry, so I'll discuss that, right? So total number of protons in the nucleus of an atom. I hope this is clear till here. Now let's deduce, we have to know the electronic configuration of first 20 elements, right? For IGCSE as well as O-level students, right? So let's deduce the electronic structure. Now see, for writing the electronic configuration or electronic structure, you will be requiring the smaller number, like that is a proton number, right? Now, because sometimes students get confused at which number should we use. So proton number is always used in writing electronic configuration and deducing the group number and period number, right? So the proton number is 11. What is the standard electronic structure, like electronic configuration? In the first shell, there are going to be two number of electrons maximum are going to be 2. And the second is going to be 8, and the third is going to be 8, and it's going to be 18. Actually, we are not going to discuss about the subshells, right? So for O levels and IGCSE, we'll just keep this simple as this: 2, 8, 8, 18, right? That is going to be the maximum number of electrons which can be occupied, right? Now here, the proton number of sodium is 11. So out of 11, how many electrons will be there in the first shell? There are going to be 2 electrons in the first shell, right? So how many will be left out of 11? Right, they're going to be 9. So we know that in the second shell there are going to be maximum number of 8 electrons, so 8. Now how many of like electrons are left out of 11? 1, right? So that 1 electron is going to be in the this. Okay. Now see, what do we like, how many shells, like if you're just going to draw this structure, like electronic structure, so if I'm just going to draw its diagram, like so I'm going to draw that there are going to be 2 electrons in the first shell. So when examiners are asking us to complete that diagram, so in the it's going to be the smaller nucleus you have to make, okay? Or you do not, you know, we're just going to write down the symbol of this sodium, right? In the first shell, there are going to be 2 electrons, which are separately, shown. And the second shell, there are going to be 8 electrons, which are going to be shown in the form of duplet, right? In, pairs. So 1, 2, 3, 4, 5, 6, 7, 8. You're just going to show with the dots, okay? Then in the third shell, there's going to be only 1 electron. So you're just going to draw it as it is, like this, okay? Now, what do we call, I hope you're getting it till here. What do we call the last shell? The last shell is known as valence shell, all right? And the number of electrons in the last shell are known as valence electrons, right? So like valence shell is the last shell, and the number of electrons in the last shell are known as valence electron. So there is only one, the number of valence electron is 1, right? So we can say it has 1 valence electrons, and the number of electrons in the last shell represents the group number, okay? Now see, the valence electrons are going to be only 1, so means group number is going to be 1, okay? So the number of valence electrons represent the group number. So there is only 1 valence electrons, means it's in group 1. All right, I hope you're getting it. And the other thing is that the number of shells, right? How many shells it has, right? So we just see that it is going to have how many shells? 3 shells, right? This is first shell, this is second shell, and this is third shell, right? So there are 3 shells, okay? So the number of shells are going to represent the period number, okay? So as there are 3 shells, means it's going to be in which period? It's going to be in period number 3, okay? I hope it makes sense. All right. So I will just give you 1 or 2 more examples, and even then and there we are just going to deduce, see, the number of electrons, protons, and neutrons. So see, we said that there are equal number of electrons and protons. So if the number of proton number is 11, number of electrons will also be 11. The number of protons will also be 11, right? So to deduce the number of neutrons, you just have to subtract the number of protons from mass number, okay? So you'll just subtract 11 from 23. We are going to get 12, right? So means the number of neutrons are going to be 12, okay? So I hope it's clear. Let me just give you another example, right? Okay. All right, so let's write down its number of electrons, bacho. The number of electrons are going to be 12. The number of protons, again, the proton number is 12, so the number of protons will also be 12. How many number of neutrons it will have? So you just have to subtract this 12 from 24, so that will be 12. Okay. Now, what will be its electronic configuration? It's going to be 2.8.2, right? What will be its group number? We just have to see the valence electrons are 2, so group number will be 2, right? What will be the how many number of shells are there? So there are going to be 3 shells. So means it's going to be in which period? It's going to be in period number 3. All right, I hope it makes sense. Now, we're just going to say that you need to do this work, like starting from hydrogen to calcium, you need to draw the number of, you can say, you can just deduce the number of electrons, protons, and neutrons, and you just draw the electronic structure, electronic configuration, and also deduce their period number. Okay, now see, you know, about group H element, right? In the periodic table, there is a noble gas group that is group 8, right? What is particular thing about group 8? This is said to be, inert gases, or you can say noble gases or unreactive gases. Okay, you can say that the group 8 elements are unreactive. These are actually all the gases and they are unreactive. Why they are unreactive? Because they have complete outer shell, right? They do not all have 8 electrons, but they have complete valence shell. They have complete outer shell. So therefore, they are said to be stable, right? They do not need to gain or, lose electrons. They do not need to form bonds. They do not form the compounds. They just exist as monoatomic gases. Okay, mono one, right? They just exist as one atomic, monoatomic gases because their outer shell is complete. Right, so in MCQs, if it is asked that they all have 8 electrons, no, they all have complete outer shell. That will be the correct marking point, right? Now, see, every element try to behave like noble gas because they want to get stable. They just wanted to have complete outer shell, right? So what do? So for that, they lose electrons or they gain electrons or they share electrons, right? So they're just going to form ions. So let's move to the next. All right. What is your work right now is going to be starting from proton number 1 to 20. You need to draw the electronic configuration and you need to deduce the group number and the period number. Okay. Okay, now what are ions and how they are formed? So ions are, we are just going to say that they are charged particles, right? Essentially, the next lesson we'll be talking about, the bonding, right? And we'll just finish up with this chapter as well. So ions are charged particles which are formed by losing or gaining electrons, right? So what do they do? For stability, either the particles lose or gain electrons, right? So we can say the ions are particles which are formed by um, losing or gaining electrons, right? Now see, like if I just give you the example of sodium, bacho. So see, sodium is said that as sodium as an atom, there were equal number of electrons and there were equal number of protons, right? So that was a neutral particle because that neutrons are electrically neutral. So overall atom has no charge because there are equal number of negative and positive charges. Okay, so an atom is a neutral entity, right? It does not have any charge because equal number of negative and positive charges. Now we said that the electronic configuration of sodium was 2.8.1, right? Now see, the valence electron is 1, it's in group 1, right? So what does it do actually? It is highly unstable. So what it wants to do? It wants to get stable. It wants to behave like a noble gas. It wants to complete its outer shell. So for that, what does it do? It was easy for it. It has to lose one electron so to get it stable, right? Now see, when it loses one electron, right? So it will have 10 electrons now, okay? Now see, when it loses one electrons, it is going to form positive ions, right? Why it forms positive ions? Because the number of protons remains the same. The number of positive, charges remains dominant, okay? So therefore, losing electrons form positive ion. I hope you're getting it. So sodium will have Na plus. We never write down plus 1. So the charge of sodium is going to be plus. It's going to form sodium ion. And the electronic configuration of sodium ion will be 2.8. All right. One more thing that here I'm just going to introduce as positive ions are known as cations, right? So usually the metals form positive ions by losing electrons. And you should know that why losing electrons form positive ions because there will be less negative charges and more positive charges. Okay? I hope it makes sense. Right. Similarly, if I'm just going to talk about, oxygen, right? So, and when you can say that metals lose electrons to form positive ions and non-metal gain electrons to form negative ions. Let's see. Like if I just talk about oxygen once again. So the proton number of oxygen is 8 and mass number is 16. So if I have to write down its electronic configuration, it's going to be 2.6, right? Valence electrons of oxygen are 6, so it's in group 6 and it's going to be in period 2. So what it's going to do now, if I'm just going to talk about there, how many electrons are there? There are 8 electrons. How many protons are there? There are 8 protons. Okay. How many neutrons are there? There are going to be 8. Yeah. Now, what, like, it's just want to complete out the shells. It's it's octave. So what it's going to do? It has to gain 2 more electrons. Okay. So when it gains 2 more electrons, it will have, you can say, 8 electrons, 10 electrons, right? Now, as it is going to gain 2 more electrons, so what charge it will have? Yeah, it is going to have more negative charges, more electrons. So it is going to have the charge that is going to be 2 minus. Okay, I hope you're getting it. Because it's going to gain 2 more electrons, so it will have 2 minus charge. And this is what will be its electronic configuration? It will be 2.8. Always remember, bacho, that the electronic configuration of ions is always, stable one. Like they always have complete outer shell. Okay. Now, we say that what is the name? Usually the students do not know. That is an anion. The negative ions are known as anion. And whenever you are just going to say that non-metal form ions, you have to use a suffix of "ide." Okay? Right? Like if this is oxygen, so its name is going to be oxide. Right? You might have heard about chloride, bromide, iodide, hydride, sulfide, phosphide. So what are they? They are actually the ions of nonmetals. Okay, I hope it makes sense. I'll just give you one more example of like nonmetal ion, and I'll try to ask you to predict its name. Yeah, and then I'll give you some homework questions so you could do that. Okay, so let's see that, and you can just even submit your answers in comment section, right? So now see if I have phosphorus. So proton number of phosphorus is going to be 15, right? I'm just going to write down mass number is going to be 31. We'll also be talking about over here we also have to talk about isotopes, right? And then their chemical properties and how we're going to find different masses of the isotopes, right? And then the bonding. Now see phosphorus, the proton number of phosphorus 15, so its electronic configuration is going to be 2.8.5, right? So it means it's in group 5. So as valence electrons are 5, and it's going to be period 3 because there are 3 shells, okay? So what is easier for, a phosphorus, as it's a non-metal, so it's going to gain 3 electrons. It's easier for it to complete its octet. It is going to gain 3 electrons, right? So when it, like right now, it has going to have 15 electrons. It's going to have 15 protons, and it's going to have number of neutrons, like 31 minus 15 is going to be 16, right? Now, as it's going to gain, 3 more electrons, right? So there's going to be 3 more, negative charges. So the charge of phosphorus is going to be like, it's going to form an ion having 3 minus charge, okay? And we say this phosphorus ion electronic configuration will be 2.8.8. Always remember, electronic configuration of ion is going to be complete, stable, right? What do we call this, what's the name of this ion? This is an anion, right? And as it's a non-metal ion of phosphorus, so the name of this ion is going to be phosphide, okay? So we say this is going to be phosphide, all right? I hope it makes sense, right? So whatever we discussed today, I hope it's going to be fruitful for you. So until my next lesson, take care. See you. Just see these questions. Try to, evaluate the electronic configuration and which ion is going to be formed. I think we did magnesium. So do it for aluminium, right? You could see the proton number and mass number using the periodic table, because you should also know how to use the periodic table, right? You just do for sulfur, and that you could just do it for potassium, you could do it for calcium, right? And you could do it for um nitrogen. Okay, so I think 5 are going to be enough. Okay, take care, see you, bye.